Okay, so we have 8th hour. You need notes. So does anybody else not get notes? So 8th hour, you need to have notes. So your substitute, who is absolutely wonderful. It's Substitute Appreciation Day, so you should appreciate the substitute. Mrs. Dahl. But you guys, so we're learning new material, correct? And again, I do not have your test graded. Some of you guys would like to retake that test without even seeing your score. That would be fine. You can do so as soon as you want. But just remember that you have the advantage of having me here for this material, whereas they don't. I will be gone. So let's make sure that we make this video nice and instructional. We will start off with a shout out from Brooke Hansen 2.
Trent, can you work for me next Saturday?
Trent, can you work for Brooke next Saturday? That's a shout out. We should preface it with, Trenton, are you awake? Okay, Trenton, wake up. All right, okay, very good. All right, well, I think that today's lesson, I think that this section, it's only 3 sections long. I think it's extremely cool. I think it's a lot of fun. I think that you guys will enjoy it. But you have to see what makes it so ingenious. Do not read The Firm by John Grisham. Watch the movie instead. Well, I'm like the anti-Mr. Haney, No, but he doesn't like math, and so I want to be anti-something else. Okay. So where are we at? Trigonometric form of complex numbers and de Moivre's theorem. Shh. So I'm going to pose to you guys a question, kind of get things started, okay? And maybe this will intrigue your mind. These are the things I thought about when I was your age, and maybe you will as well. So no, square root of 1 is plus or minus 1, obviously, right? So what about square root of negative 1? We've identified that to be plus or minus I. Okay? Everybody okay? Well, how about this? Cubed root of 1. 1. No plus or minus, just 1. Cubed root of negative 1 is negative 1, because negative 1 times negative 1 times negative 1 is negative 1. So how about this? Plus or minus 1. This is a little bit more difficult, isn't it? I mean, if you think about it, people. Yeah, exactly. Very good. This is actually equal to the square root of positive or negative I. So it raises the question, what is the square root of I? I mean, the fundamental theorem of algebra tells us that we have to be able to come up with, solutions for given equations. This creates a very interesting type of solution. How do we solve something like that? Because we can model this equation, right? We could say, well, x to the 4th plus 1 is equal to 0. And then we would subtract the 1, and we get x to the 4th is equal to negative 1. We would take the 4th root. And so we know that this equation right here has 4 solutions. But how can we express them in a different way? And we haven't done that yet. What does that look like? What does it look like? Can you take the square root of I? And you need to let go of everything that you know about mathematics and say this, okay? You have to say, I'm going to let go of the whole number system idea, and I'm going to trust that if mathematics says that given a 4th degree equation, there are exactly how many solutions? 4, that I have to be able to write the solution to that. Trigonometry allows us an amazing opportunity to write those solutions in something called de Moivre's theorem, which we will lead up to. First, let's start by transforming numbers into trigonometry, complex numbers into a trigonometric form. Okay, let's start by talking about the graphing of complex numbers. We have what we call a real axis. This is not x and y. This is real. This is imaginary. This is referred to as the complex plane. Oh, you don't want that one. Two kinds of people in this world, Sarah. Low, low maintenance Simons. Okay, we'll stop there. All right. So what we want to be able to do is we want to start by graphing, and imaginary numbers are often referred to as z sub something. So you see z sub 1 is equal to 2 plus 4i. We graph the real part on the real axis, and we graph the imaginary part on the imaginary axis. So this is not going to be difficult. We would say 2, we would go over 1, 2. And for plus 4i, we would go up 1, 2, 3, 4. And we can put that spot there. I am going to attach a line to it from the beginning. So, because that line is going to be very important to us in the near future. But that does represent the graph of z sub 1. Any questions how I got that? Okay, on your own, go ahead and graph z sub 2. I'll graph it along with you, see if you got the right thing. She always yells. She tries to match my voice. She realizes her class can't hear when I talk. I have such a deep, powerful voice. I did tell Aethar there's 4 types of women, and there are, but there's 2 types of people. very, very good, Larry. Wow. All right. Everybody got that? Okay, then let's just do another basic piece. You're going to be asked to do addition, subtraction, multiplication, division, and in particular, in this case, you have z sub 1 plus z sub 2. Okay? So it says I want to graph z1 plus z2. In order to graph that, let's just combine our real terms and our imaginary terms. If I take 2 plus 4i then, and add that to negative 1 minus 5i, I should get my new term. I get positive 1 minus I. So I can graph that by going over 1 and down 1. So again, that would be the graph of, as we said, z1 plus z2. So if this is the first question on your test, can you perform this operation? Okay. All right, Stewie. We're good, I think. How about, does that say negative z sub I? Let's just make it negative z sub 1, okay? Oh. I must have hit the wrong number. So negative z sub 1. So what's negative z sub 1 going to be? Very good. You would just distribute the negative through. So now we have a new number, which is, no, we're just plot points. Just having fun, you know, chilling. Chilling, relaxing, trying to stay cool. Shooting some b-ball outside of school. What a couple of guys were up to no good. They started making trouble in my neighborhood. I got one little fight. My mom got scared. She said, "You're moving with your auntie and uncle to Bel Air." You guys know the whole Fresh Prince Beller. Okay, all right, there you go. All right, okay. Keep going. Okay, all right. All right, so how about 1 half Z, what? How about 1 half Z1? 1 half Z1, what's that? Very good. 1 half Z1 is going to be 1 plus 2i. Just distribute the 1 half through. And so I'll go over 1. And I'll go up 2. And if you notice, that does put me right in line with Z1, doesn't it? It just makes it half the length. Does that make sense? This can be important as we move forward. See it all here? Okay. I thought Keely meant keep going as in like keep going with the lesson. You wanted me to rap. Okay. All right. We don't have time for that. We need to learn about a modulus. Okay. And yeah, I actually misspelled it here. My apologies. Modulus. Modulus. So I'm going to refer to the modulus. And the modulus is going to be a very really a fundamental part of us moving forward through the entire rest of this unit. And the modulus of the complex number z equals a plus bi is expressed as that. You could refer to it, I suppose, as absolute value, which is... Now, hold on real quick, okay? This is extremely important that you understand this concept. Are you ready? Absolute value. If you were to define absolute value of just a regular number, think of the real number system. Define absolute value for me. How would you define it? Distance between that number and 0 on the number line. Very good, Emma Bailing. So, let's take that and apply that to the complex plane. The absolute value of a complex number would be the distance of that complex number from the origin. Yeah, look at this. Check this out. So look at Z1. If we were to find the distance of this complex number from the origin, what would we have to use? The Pythagorean theorem. You guys are so smart. Okay. Very good. The absolute value of a complex number is the distance that it is from the origin, which you would calculate by using the Pythagorean theorem. So it is the square root of a squared plus b squared. So it says find the modulus of z1 and z2. Well, this is exciting. We have z1 is 2 plus 4i. So z1 is 2 plus 4i. And z2 is equal to negative 1 minus 5i. Is that correct? So if I want to find the modulus, I express it as follows. I would say, well, that's equal to the absolute value of z1, which is equal to what? What do I do? Very good. Square root of 2 squared plus 4 squared. We don't do anything with the I. Okay. And 2 squared is 4. 4 squared is 16. Add those together, you get square root of 20 can be reduced to 2 roots of 5. That would be the absolute value of an imaginary number. That's the second type of problem on your test. Could you do that? Okay. So far everything's pretty simple, right? All right, let's keep it like that. All right, absolute value of the second one. Square root of 1 plus 25, or the square root of 26. Can that be reduced? No. Sad day. It's okay. It's okay, square root of 26. You'll have your time in the sun. You're gonna go home, listen to the videos to hear me rap again. All right. It was kind of fun. All right, you guys are so dorks. Okay. All right, flip it over. Oh, I found. Oh, you wrote your name on mine. shouldn't do that, Sarah. Okay. Yeah, whatever. Stop. Done with this. Okay. So here's the magic. So you have to have 3 skills. 3 skills. A, can you graph imaginary numbers? Or complex numbers, I should say. Okay, great. B, can you find the modulus of a complex number? Okay, C, can you express a complex number in trigonometric form? Sam. I see. Every time she's going to be negative, I'm going to call her Sam. Lindsay. She shook her head. That's when I say Sam. Yeah. Okay, let's try this then. Suppose I have a complex number. And I want to take z equals a plus bi, and I want to express it differently. Okay? This can be rewritten as something else. And I'm going to show you. And you're going to be able to come up with it all on your own in your brain. Okay? Which is really cool. Here's the real axis. So if I look at this, it makes a triangle. All triangles have an angle that we refer to as theta. What is this x length? X. In terms of a plus bi, what is this? A. In terms of the height, what is this? B. Very good. So the radius, we normally call this r, right? That's equal to the absolute value or the modulus of the complex number, which is the absolute value of z. Let's stick with r, though, for this purpose, okay? And we'll define it here in just a second. What I want to do is I really want to get rid of a, and I want to get rid of b. And so I'm going to rewrite things using sine and cosine. Can you tell me what is cosine of theta equal to? A over r. So would you agree that I could then rewrite this as r cosine of theta is equal to a? So now I've gotten rid of a, right? I can get rid of that. Then I can do another part. I can say sine of theta is equal to b over r. So therefore, r sine of theta is equal to b. We're just doing SOHCAHTOA. SOHCAHTOA. Or you just remember everything because you bought a bunk bed and you pasted all of your formula sheets to the wall so you could read them before you go to bed at night. Okay, so look at how I can rewrite this now. I have as follows. Z can be rewritten as, instead of A, I have r cosine of theta. And instead of B, I have r sine of theta, and I have to remember the imaginary part, right? Do you see that? So I'm going to do one last step here. Z is equal to, I'm going to factor out the r, and that will be cosine of theta. I'm going to write the plus I sine of theta, just like so. Now, in order to generate that trigonometric form, now you guys got to understand how cool this is, okay? Cosine of theta and sine of theta, they kind of circulate around and around, don't they? I mean, they're periodic. They repeat themselves. But if we were to just take a and b on the number line, like so, look at a and b. You know, a and b are just integers, and they would, they'd just go on forever in one direction on the number line. They don't ever repeat themselves, do they? So you have this kind of periodic repeating piece, and it's going to come up very helpful as we look for roots later on. It's very, very interesting piece. But there's two conditions that have to be satisfied here. First of all, what is r? Well, r is equal to the absolute value of z, which we said is equal to the square root of a squared plus b squared. So in order to write a number in trigonometric form, a complex number in trigonometric form, we have to first be able to find r. And r will be defined again as the absolute value of z, or the modulus. Is that okay? So the only other thing we need then is theta, right? Well, there's one trig ratio we didn't express up here. We did sine, we did cosine, but we didn't do... Right, so tangent of theta is equal to b over a. So theta has to satisfy oh no. No, it's just the smart board got stupid. It pauses. Let's wait. Wait till you decide to wake up. There it turns red. Yeah, it's still recording because I can't even press the stop button on the recorder. Okay, there it goes. All right, so tangent of theta is equal to b over a. There you have it. So the two pieces that we have to find are r and theta. R is equal to the absolute value of z, the modulus, which is square root of a squared plus b squared. And theta satisfies tangent theta equals b over a. Do you see how often the Pythagorean theorem comes up? It's everywhere. Thanks, Larry. All right. Write the following complex numbers in trigonometric form. This is the last piece that we're doing today, and then you're going to have some time to work. Okay? So, your assignment. I must start by finding r. R equals what? 2 roots of 2. Very good, because you have the square root of 4 plus 4, which is the square root of 8, which is 2 square roots of 2. Very good. I'll write it better so that 8th hour can see it. Yes. Tells me something I don't know. Okay. 2 plus 2i's. That could be in the first quadrant, or the second quadrant, third quadrant, or fourth quadrant. It's in the first quadrant. If you think about it, you would go over 2 and up 2. That's very important. So when you solve for theta, it's going to be between 0 and 90. We are going to solve in radians for trigonometric form. So it's going to be between 0 and pi over 2. And it must satisfy tangent of theta equals b over a. What is b? 2. What's a? 2. So you have 2 over 2, which is... So tangent of theta has to satisfy being equal to 1. Where is tangent of theta equal to 1? 45 degrees, or... So in the first quadrant, theta would be pi over 4. Very good. Remember we just took a test on solving equations? This would be like the easiest question on your test if you had to do it. Okay. So there we have theta is equal to pi over 4. Let us now write the trigonometric form of the number. So z is going to be equal to, I take r, 2 square roots of 2, times cosine of Yep. Okay, I'm sorry. You guys are getting a little confused, so let me slow down. It's okay. Okay, so we have z is equal to r times cosine of theta plus I sine of theta. So I have z is equal to 2 square roots of 2 times the cosine of pi over 4 plus I sine of pi over 4. That may look bad, it may look bulky, it may look not very useful, but in fact, this will be very, very useful to us down the road. It was through the development of the complex plane and the and trigonometric form that we were able to get, as I said before, alternating current of electricity. So, Very important in physics and current flow. So you guys don't write this down, but I need to show you something so you connect your knowledge a little bit further. Do you know the value of cosine of pi over 4? Right, so watch what happens here. You have z is equal to 2 roots of 2 times cosine of pi over 4 is the square root of 2 over 2. Okay, plus I times what is sine of pi over 4? If you were to distribute this through, then you would just come up with what you started out with. Right here. So I'm just saying that, you may say, oh, well, we know the cosine of pi over 4. Yeah, well, we would just transform that back into then, regular form. So you could do either or is kind of the point. But we're done with the red. You don't have to do the blue. That would be, kind of just going back to where we started. Okay. See if you could do the second one on your own. Try -3 plus 3 square roots of 3. See if you can write the trigonometric form of that number in complex form. I'm sorry. See if you can write that complex form in trigonometric form. So it should look like r cosine of theta plus I sine of theta. Yes, I'm sorry. Yep, these notes have not been modified from last year. There's an I right there. So it should be -3 plus 3 square roots of 3i. Okay, let's just confirm how we got it. So again, 8th hour hasn't seen us. They didn't really have any time to work either because I pressed pause. That's how it works for them. So you have r is going to be equal to the square root of a squared, which is 9, plus b squared. 3 square roots of 3 squared is 27. So you get the square root of 36, which is 6. So r is 6. We have that. A lot of you guys recognize that -3 plus 3 square roots of 3 is going to be back 3 and up a certain amount. So you're going to be in your second quadrant. So this is going to be in your second quadrant. Therefore, you need to account for that in your angle when you work with theta. So we need to find theta. We set up tangent of theta is equal to b over a, or negative square root of 3. And then you took out your graphic organizer, which you love, and you say, thank you, Mr. Gins, for making this great graphic organizer. You're welcome. You're welcome. You're welcome. Yeah, exactly. As you look at it, you see 2 pi over 3 or 5 pi over 3. And how do you know which one to choose? Yeah, 2 pi over 3 is in the second quadrant. So theta is going to be 2 pi over 3. Now, everybody pause because I want to show you, what do you do if it's not on your graphic organizer? Very good. You would use your calculator and do the inverse. So let's make sure we can do that first. Okay. So if I take out my calculator, mode, I'm in degrees. So watch. If I go second, tangent inverse of, and I'm just going to do the positive value, square root of 3, that's going to give me a reference angle. Okay. I get 60 degrees. So if I'm working with, say, 60 degrees, you guys said I'm in the second quadrant, right? So 60 degrees. So 60 degrees in the second quadrant would mean what angle do I have? 120 degrees, which is 2 pi over 3, right? So if you want it, but, let's say it did come out to be the appropriate degrees, you always have to put it in radian form. If I took my calculator and I went, I said mode radians, and I tried it again, now I get 1.047. Well, then you're just going to have to, do that same process. 1.047, 1.047, but instead of subtracting it off 180 degrees, I subtract it off of pi. And 3.14 minus 1.047 gives me 2.093, which is the decimal form of 2 pi over 3. My point is, it's not always going to work out just super nice and perfect to be 2 pi over 3. So you got to be ready to work through it. You guys have already had a whole quarter of trigonometry, so that's not going to be any issue for you. Okay, we try the last one, and then you have your assignment. Okay, negative 2i. What's different about this one? There's no a value. So I have 0 minus negative 2i, I guess you could write it, okay? Or 0 plus a negative 2i. Whatever you want to write it is fine. So I'm going to work through this. I'm going to say r is equal to square root of 0 squared plus negative 2 squared. It's going to be the square root of 4, which is 2. Yep, so it's just 2. For theta, which quadrant am I in? You're on the bottom. You're on the lower part of the y-axis. If you go over 0 and down 2, you're going to be sitting right here. Exactly. So Larry sees something that I think a lot of you should connect with. If you just drew this out right away, you could tell. You didn't even need to figure out r by doing square root of a squared plus b squared. You could tell that you have a length of 2, right? And what is your angle value here? 3 pi over 2, or 270 degrees. And so, you could go through the same process, but sometimes it's just as easy to just draw the shape and recognize exactly what it is, okay? And if you can do that, then good for you. Otherwise, you would have to go through the rest of the process. So what we have here now is we have z is equal to r, which is 2, times the cosine. I always do that. Cosine of 3 pi over 2 plus I sine of 3 pi over 2. Now, last thing, just to try to connect your learning, what is the cosine of 3 pi over 2? Well, 0. Look, guys. Look. 2 times 0 is 0. That's what you have here, right? What is the sine of 3 pi over 2? Negative 1. If you take 2 times negative 1, you get negative 2. Here's your negative 2i. So see, they're the same. They're just expressed differently. Okay? All right, you're ready for your assignment. Okay, I do need to warn you guys that I'm very happy that it sounds like a lot of you feel like you actually did pretty well in the last test. Some people don't feel that confident, but we did take just a little bit more time than I did last year, so we are just a tad bit behind, and that maybe helped you do a little bit better. We do have to keep a pretty good pace in order to finish what we need to do by the end of the year. So we're not slowing down, okay? So here's your assignment. Yep, snow days have slowed us down. Other things have slowed us down. Big 9, leaving for wherever you guys went, slowed us down. Winona. I thought everything musical and fun happened in Winona. I don't know. People have been telling me great things about Winona. All right. So, so here's your assignment. You go ahead and get to work. And, yeah, keep up the pace, okay? It's make sure you're doing it. So all those of you going to True Team tonight, raise your hand. Okay, so there's 4, 5, 6 of you. I would highly recommend that you work on this on the bus there and on the way back. I will not be on your bus. But you don't need me because you have other people who can help you. So, good luck. Late at 8th hour, who wants to have a shout-out send-off to 8th hour? Trenton, wake up.
Hi, Kelly.
That's hi to Kelly Sanderson from Kaylee Drescher. Larry Holcomb.
I'm not actually sure who's in this class, so I'm just going to say hi to everyone because I feel like you all know me well enough.
I do know everybody in that class, and who? All right. Name everybody in the class. Well, there's the president, Robin Victoria. She's very important. Kemma Bergwin, Megan Boss, Dylan Skywalker, Cody Scherf. Lucas Hansen usually comes in. Anna Anderson sits up front, but she's gone a true team. Where's the hacker who's also gone a true team? Tower Vandenhoevel. Yep, Tower Eggy. Jesse Olsen, Andy, Bailey, Region, Mallory, Casey Gilbertson. I know I've... oh, we can't leave out... No, Sarah Sanders is right back there. We also have Hannah DeVries. We have Tara Westland. What worry I'd forget about her. We also have Jensen Goodall. And that... Haley Schrader. Billy Barb. Goodbye.